All right, in 11.5, we're going to look at two-way frequency tables. You've talked about two-way tables in the past. You've spent most of your time filling them out, and now we're going to come up with some percentages and some frequencies about them. So marginal frequencies are the totals in the table. So what I've just highlighted in green, those are technically your marginal frequencies. They're in the margins, the edges. The joint frequencies are the counts for each cell. So 50 people, 90 people, 20 people, 40 people. Those are the joint frequencies. Now what do they mean? Well, let's see. This box right here, 20 out of 200. 200 is the total people that were surveyed. And this says that 20 of these people were adults that prefer going to the movies in the afternoon. 20 divided by 200 is 10%. Over here, this marginal frequency says that altogether there were 140 students out of 200 respondents, so that's 70% of the respondents were students. All right, that's a little background to get you thinking, get you started. Now let's take a look. So here we got a nice small data set. A class of 30 students recorded their grades and their genders. I will tell you, reading carefully is important here. There's lots of details. How many male students earned A's? So we need male students earning an A. 5. 5 students. Done. Letter B, what percent of students? Now you're looking at every student here, so all 30. That is my denominator. Of those 30 students, how many are females that earn B's? So I go to the female row, the B column, and there's a total of 4. Now we want a percent, so I better multiply by 100. I would simply drop that into decimals. 4 divided by 30 times 100 gives me 13.33%. If you're not told how to round, rounding to the nearest hundredth, 2 decimal places, is a fair assumption. Letter C. What percent of males earn C's? So now we're not looking at everybody, we're just looking at the male students. So out of those 18 individuals, how many of them earn C's? 7. We want a percent again, so 7 over 18 times 100 gives me about 38.89%. All right, continuing on. Letter D. What percent of A students were males? So I'm looking only at my A's. So out of these 11 people, how many of them were males? 5. And a percent again, so 5 out of 11 times 100 is 45.45%. All right, last one for this data set. Which is more likely, a female student that earns B's or a male student earning A's? All right, so female earning B's. So I'm only looking at my females. So out of these 12 students, how many of them earn B's? 4. So 4 out of 12 times 100 is 33.33%. So a third. Then we repeat the process for males earning A's. So we're going back to our males. Out of those 18, 5 of them earn A's. So 5 out of 18 times 100 is 27.78%. So which one is more likely? Females earning B's. Why? Because that was 33.33% compared to 27.78%. All right, moving right along. Next one. So now we've got some spectators entering a stadium, and they're deciding whether they want to cheer for the Bears or the Tigers. So letter A, what does the joint relative frequency 65 over 230 represent? So 65 over 230. So 65 represents males rooting for the Tigers out of 230 the total. So there are 65 males rooting for the Tigers, or cheering for Tigers, out of all respondents. And then 72 over 121, so I'm going to find my 72 and my 121. Now this is a conditional relative frequency because the 121 is only talking about the people that are rooting for the Bears. So out of 121 Bears fans, 72 of them are male. So we're no longer looking at the 230 people that were surveyed. We're only looking at the ones that are cheering for the Bears. All right, letter C. What's more likely? Males that cheer for the Bears. So out of my males, so out of 137, 72 are Bears fans. So 72 out of 137. 52.55%. And then females, Tigers. So out of the females, the ones that cheer for the Tigers, 44. 44 out of 93. Times 100 is 47.31%. Okay, so which one is more likely? Males cheering for the Bears, because that percentage is higher. All right, that's what we got for 11.5.